So in the following question, you can picture that I have my hand right here. And what I'm doing is I'm pushing the blocks. And I will be pushing them to the right. And we can see we've indicated this here by saying that I have a force applied of 20 newtons to the right. Now let's think about what happens when it's asking about the acceleration of the system. Because I'm pushing all three blocks to the right, block A, B, and C, they're all going to accelerate at the same rate. And we know that for our net force is going to be equal to mass times acceleration. Now, if my hand is here on the left and I'm pushing all three of these blocks to the right, I know my mass is going to be the 5 kilograms, the 3 kilograms, and the 2 kilograms, giving me a total mass of 10 kilograms. Now we know the force that I'm putting in there is 20 newtons. We're going to assume a frictionless surface to keep this simple. So we're going to plug in, and we're going to say 20 is equal to 10A. And when we divide both sides by 10, we end up with 2 meters per second squared to the right. That is going to be my acceleration. So we know that block A will be accelerating at 2 meters per second squared, block B will be accelerating at 2 meters per second squared, and block C will be accelerating at 2 meters per second squared. So now let's talk about the second point right here, where we talk about the force between A and B. Now if we look at, if I was to put my hand like right here, so talk about the force that's occurring this way. You can see in this case that this action force would be only pushing along 5 kilograms of mass. So it's going to have a mass of 3 plus 2 is 5 kilograms. Now we know the acceleration is going to be 2 meters per second squared to the right. So therefore my force is equal to mass times acceleration. 5 times 2 is going to be 10 newtons to the right. However, Newton's first law says for every action, there's an action equal in magnitude but opposite in direction. So we can think of this sort of being as my action force because it's being accelerated to the right, but then we would also have a reaction force. Now these two blocks are accelerating at the same rate from one another. They're not getting closer, they're not getting further. So if the force this way is equal to 10 newtons to the right, that has to be true in the opposite direction as well. This force here also has to be 10 newtons to the left. Think about what's happening. The 5 kilogram block and the 3 kilogram block are both accelerating, but they're not accelerating faster or slower than one another. Therefore, they're going to stay beside each other the whole time. We'll try another example. We'll try number 3. For number 3 here, we have force between B and C. Now, if we're pushing to the right, the only mass I'm pushing is my 2 kilogram block. And we know the acceleration that this 2 kilogram block is going to be experiencing is going to be 2 meters per second squared to the right. So when I plug it into F equals ma, it's 2 times 2, which leaves us with 4 newtons. Now we're going to have an action force of this going at a force of 4 newtons to the right. That would be like our action force. But remember, the 3 kilogram block and the 2 kilogram blocks are staying together. As a result, there has to be a reaction force backwards where the force is the exact same value of 4 newtons to the left.